So we can have skewed distributions, or we can have a symmetric distribution like this one, where the most popular answer is right in the middle, and then as you go to either extreme, there's fewer and fewer data values. When a distribution is perfectly symmetrical, the mean and median are the same. And if you have a roughly symmetric distribution, then they might be close to each other. So this is a left-skewed distribution. Anytime the data is skewed, the median is a better measure of center than the mean. So there's a right-skewed distribution. Here's skewness in different displays. So the top of this graph has histograms, skewed to the left, skewed to the right, and then you can also see the skew in this box plot and that box plot. And you can even see a skew in the stem plot, the stem and leaf plot here. So this is skewed to the left. So turn your head sideways. This is skewed to the right, and this is a symmetric distribution. This is another cool graph I found somewhere. A uniform distribution just means that there's 25% of the people in each quartile, and they're evenly spread out. This is not evenly spread out. You have more people in the middle. 25% and 25% are kind of close together, and then this 25% is more spread out, and that 25% is more spread out. There's a rule in your book that says that any value bigger than Q3 plus 1.5 times the IQR. So this is a formula that gives you a cutoff, and anytime you have a data value bigger than Q3 plus 1.5 times the IQR, that data value is a suspected outlier. There's also suspected outliers below Q1 minus 1.5 times the IQR. Now, if you have a suspected outlier, I don't actually know what would make it a definitive outlier. So we'll just have to leave that question to be answered at some point in the future. Standard deviations is another way of measuring how spread out the data is. And we're going to go deep into standard deviations soon. So instead of talking about percentiles and quartiles, we can measure how far you are from the mean. And this is one standard deviation above the mean, 2 standard deviations above the mean. Once you get to 3 standard deviations above the mean, there's almost nobody out here on a bell-shaped curve or normal distribution. And this mu is the mean of the population. 1 standard deviation below, 2 standard deviations below. Once you get here, almost nobody else is lower than that. So this just shows you that concept that if we have a normally distributed population, most people are in the middle, very few people are at the extremes. So this goes a little deeper into that. 68, 95, and 99. Now these percentages would be different if the distribution is not bell-shaped. And we will come back to the empirical rule later.